Now see here, this is the device which is based on actually electromagnetic induction, or we can say mutual induction. So, transformer is actually a device which is used to increase, or you can say simply step up or step down alternating voltages or current. Now see here, in transformer, what happen here, there is a soft iron and these two coils are wound here in this manner or in this manner. Here these two are wound separately here on the soft iron, and here they are wound over each other here in this case here, and this one is called here the primary coil and this is called secondary coil, and here also this is primary and this is secondary coil. Here the coils are wound over each other here on the soft iron core. Now what happen in mutual induction, actually when you connect here, apply here the primary voltage here in this case, what happen, electromagnetic induction takes place, that means EMF is induced, that EMF that EMF, induced EMF opposes the increase or decrease of the current. As a result, EMF is induced in the secondary coil, and this EMF whatever is in the secondary coil, that we can take outside here across this arc, that we can take as output. Here in this case, actually when we write EMF, we can write EMF is equal to voltage here. If it is not was so, then what will happen, the current will be infinite in the primary circuit, in the primary coil, which is not possible here. So, when the EMF or alternating voltage is applied in the primary coil, mutual induction takes place and EMF is induced in the secondary coil. Whatever the EMF is induced in the secondary coil due to change in the magnetic flux linked with the secondary coil, that depends on the number of turns. So, we can actually write in this case, when you are taking here E is equal to, or you can say EMF in the secondary coil, we can take minus Ns d phi upon dt. Similarly, we can write EMF in the primary coil, that is also minus Np d phi upon dt. When you divide these two, you will be getting Es upon Ep. Also you can write Vs upon Vp is equal to Ns upon Np. So, this is the EMF or the voltage in the secondary coil and the number of turns in the primary and secondary coils. So, now in this case we have got Es upon Ep is equal to Vs upon Vp is equal to Ns upon Np here, and now we can take in this case, if there is no power loss in the circuit, then we can write actually here Vs Is is equal to Vp Ip, that is input power is equal to output power. And now from here we can write Vs upon Vp is equal to Ip upon Is is equal to Ns upon Np here. Ns is the number of turns in secondary coil, Np is the number of turns in primary coil. Suppose you are taking Ns is greater than Np, then you will be getting Vs is greater than Vp, and that is called a step up transformer. We call it a step up transformer. If you are taking Ns is less than Np, then output voltage, that is secondary voltage, will be lesser, and that can be written Vs is less than Vp, and that is called here is step down transformer. It means by increasing the number of turns in secondary coil, we can increase the voltage, and also we can decrease the number of turns in the secondary coil. By this way we can decrease the voltage, output voltage. So, here actually transformer is a device which is used to step up or step down alternating voltages here. So, now here we can get also this Is and Ip also, we can get the values of the current, and we can write Ip is equal to Ns upon Np into here Is. Similarly, we can write Is is equal to Ip into here, that is Np upon Ns. So, by this way we can calculate Ip and Is also here in the circuit here. But see here in this device transformer here, there is some sources of energy loss, or you can say energy is lost due to many sources. One reason may be the flux leakage. If the winding of the coil is not done properly, the flux may go out, or there is the flux leakage may takes place. Because of that, effective transformer cannot be made, or there is loss of energy. Also here, for making the coils, copper windings are used which has got resistances. So when the current flows through it, value of the current here, and because of that heat is produced and some energy is lost. And also in the the laminated plates are used here, there are eddy currents. Because of the eddy currents also energy is lost. And also there is a hysteresis, that is a magnetization and demagnetization of the soft iron. Because of that also energy is lost. So there are these different types of the sources through which energy is lost in this process.